Hey math friends, this is Pre-Calculus section 6.3 day 1 notes. Today we're going to start by talking about trigonometric functions of angles. So we have a right triangle here, everything we know about a regular right triangle. We have our angle theta, we have the side adjacent, the side opposite, and the hypotenuse. Now let's go ahead and draw this right triangle in the coordinate plane in standard position. So here's our triangle. Oh boy, that was a terrible straight line there. Let me try again. Here's our triangle. There we go. Our angle theta is right here. So this side adjacent to theta is our x value along the x-axis. This side opposite to theta would be our y. And our hypotenuse here we're going to call our r, or our radius. We already know by SOHCAHTOA our 6 trig functions, but now we're going to write them in terms of this right triangle here that we just drew in the coordinate plane. So we're going to be using x, y, and r as our sides. The sine of theta then would be opposite over hypotenuse, y over r. Cosecant would be the reciprocal of that, so that would be r over y. Of course, we have one situation that we have to be concerned about here, and that is that y cannot equal 0 because otherwise cosecant would be undefined. Cosine of theta is x over r. Secant would be the reciprocal, or r over x. Again, for secant, x cannot be 0 or secant is undefined. Tangent of theta would be y over x, or sine over cosine. X cannot be 0 or we're undefined, and cotangent, flip that over, would be x over y, where y cannot be 0. Reference angle, and in this chapter, before, remember we called it t-bar, now we're going to call it theta bar, is the angle formed by the terminal side of theta and the x-axis. Same definition as before. It is always an acute angle, meaning less than 90 degrees, right? Which is in quadrant 1, right? So same rules apply for reference angles in this chapter as they did in last chapter. We're looking at the shortest distance between the terminal side and the x-axis, and this angle is always going to be positive. Now we're going to do a couple of examples where we are going to find the reference angle for a given angle. And our first example, theta is 240 degrees. Well, 240 degrees is down here in the third quadrant. So here's our terminal side, here's our initial side, here's our angle theta. Okay, so we know that our theta bar, or our reference angle, is just going to be the shortest distance from the terminal side of the angle to the x-axis. So here's our theta bar. And we know that if theta is 240 degrees, basically that is 60 degrees past the x-axis, so that tells us that our theta bar in this situation is 60 degrees, right? And again, if you want to know how I figured that out, theta bar is going to be equal to 240 degrees minus 180 degrees, which gives us 60 degrees. In our second example, theta is given to us in radians. That's fine. We can switch back and forth. 5 pi over 3 is going to be way over here in the fourth quadrant. So here's our initial side, here's our terminal side. This whole thing is our theta. So our theta bar is going to be this angle right here. So in this situation, our theta bar is going to be equal to 2 pi minus 5 pi over 3, because that'll give us what that angle is that's left there, which if we get a common denominator here, we're going to have 6 pi over 3 minus 5 pi over 3, which tells us that our reference angle is pi over 3, which you probably could have told me without doing any of that math. Okay? All right. The next thing that we're going to talk about is a quadrantal angle. A quadrantal angle is an angle whose terminal side is on an axis, any axis, okay? Not the x-axis necessarily, could be y-axis as well, okay? So these are always going to be, because the terminal side has to be on the x-axis or the y-axis, it should make sense that these quadrantal angles are multiples of 90 degrees or pi over 2 radians. They would have to be if they have a terminal side on the x-axis or on any axis. So if you look at our first example here, it says to find the exact value of the trigonometric function. Well, we know that 90 degrees would be this right here, right? Here's our 90-degree angle in the coordinate plane. And if we want to find the sine of 90 degrees, think about what that ordered pair here is at the top of the circle. That's the ordered pair 0, 1. And we know that the sine is the y value of the angle. So the sine of 90 degrees is 1. Tangent of pi, well, pi, this would be our initial side. This would be our terminal side. So theta here is a straight angle. And pi is over here. The ordered pair for that point on the unit circle is -1, 0. We know that tangent is sine over cosine, or y over x. So in this case, y divided by x is going to be 0 divided by -1, which is 0. And then finally, cosine of 720 degrees. 720 degrees is 2 times around the unit circle, right? So basically we are back at our starting point here. We know that this ordered pair terminal point is 1, 0 on the unit circle. If we want the cosine value, then we want the x value of our ordered pair. So we know that that is going to be a 1. For our last few examples, we're just going to do some more practice finding the exact value of some trig functions. And I'm actually going to show you 2 ways to do this. The first way we're going to call method 1 is going to be using the terminal point on the unit circle. And then the second way that we're going to look at it is in terms of a right triangle. Okay, so for our first example, if we are looking at cosine of 150 degrees, first of all, if we were to draw that angle, we know that that's going to be in the second quadrant. Sorry, I'm dealing with kind of a small coordinate plane here. So here's our theta. So then we know that our theta bar would just be that distance from the terminal side to the x-axis. So that right here would be our theta bar. So we know our theta bar in this picture is going to be 30 degrees. Okay, well, again, we can think about this in 2 different ways. The first way is we can look at the terminal point on the unit circle at that ordered pair, and we know that the terminal point at 150 degrees is negative square root of 3 over 2 comma 1/2. And the cosine of the angle is always the x value. So we know that this is negative square root of 3 over 2. Okay, so basically I just did method 1. Using the terminal point, we know that our theta bar here is 30 degrees. We know the terminal point for 30 degrees is square root of 3 over 2, 1/2, but because we're in the second quadrant, it would be negative square root of 3 over 2, comma 1/2. Okay, so method 1, using the unit circle, using the terminal point, knowing that the cosine of the angle is the x value. In method 2, we are going to instead just look at a right triangle in the second quadrant. We know that we're looking in the second quadrant because we are looking at the 150-degree angle. So if we draw the triangle here in the second quadrant, here's our right angle. We know that this angle right here is 30 degrees because that's going to be our reference angle that we already found. And if we use our right triangle, our special right triangle relationships, we know that this side is 1, the hypotenuse is 2, and this leg here is negative square root of 3. And you could get that from the cosine and sines from our ordered pairs as well, you know, just from the unit circle. But now we're just looking at the cosine of 30 degrees here, which in this case would be x over r, or negative square root of 3 over 2. So we get the same answer whether we look at this problem in terms of terminal point on the unit circle or whether we look at it in terms of a triangle in the second quadrant. The next example, we're going to do the same way. If we're looking at the sine of negative 300 degrees, well, negative means we are going clockwise instead of counterclockwise. So our initial side is going to be here, our terminal side is going to be here, and our angle is going to look like that. This is going to be our theta. So then our theta bar is going to be that distance right there. Okay, so theta bar, hopefully you can tell here, is a 60-degree angle. We know that the terminal point of that is 1/2 square root of 3 over 2. So the sine value from the terminal point is going to be our y value, so that tells us here that our answer is square root of 3 over 2. We can also look at this in terms of a triangle. So this time our triangle would be in the first quadrant. There's our right angle. This angle right here is going to be 60 degrees. So we know from our special triangles that the leg adjacent is 1, the leg opposite is square root of 3, and the hypotenuse is 2. So then we know that our sine of 60 degrees, sine is opposite, or y, over hypotenuse, which is r, right? So y over r, or in this case, square root of 3 over 2. Third example, we are looking at the angle 7 pi over 4, which is going to be right in the middle of the fourth quadrant. So here's our initial side, here's our terminal side, here's our angle theta. So that tells us that our theta bar is this angle right here, which is going to be pi over 4, or 45 degrees. And since we're in the fourth quadrant, we know that that terminal point is square root of 2 over 2, negative square root of 2 over 2. If we want the tangent, then we want y divided by x, or sine divided by cosine. So negative square root of 2 over 2 divided by positive square root of 2 over 2 is going to give us a tangent of negative 1. If we look at this in terms of a triangle in the fourth quadrant, here's our right triangle. We know that our angle right here is a 45-degree angle. And we know that this side is 1. Since this side is going down, it's a negative 1. And the hypotenuse of our right triangle here is square root of 2. Our tangent is our y value divided by our x value. So in this case, it's going to be equal to negative 1 divided by 1, which is negative 1.